You think the word move, and a cursor slides across the screen. No mouse, no keyboard, just a thought turned into action. So how do you pull a single idea straight out of a living brain? First, where does a thought actually live? Deep in your brain, tiny cells called neurons send little jolts of electricity. One neuron firing is like one blinking light, but billions blink together, and every intention, like move up or move left, has its own signature pattern. Here is the hard part. Those electrical whispers are incredibly faint, and your skull is in the way. Reading them from outside your head is like standing outside a stadium and guessing the score from the muffled roar. To hear one clear voice, you get close. So the sensor goes inside, wires thinner than a strand of your hair or a soft, flexible mesh sit right next to the neurons. That close, they feel each tiny voltage spike the moment a neuron fires, like a microphone pressed against the singer's lips. Each spike is far too weak and too fast to use raw. So a tiny chip does two jobs at once. It amplifies the faint spikes to make them loud enough to read, and it turns thousands of them every second into numbers a computer can understand. Now, the real magic. A machine learning model, the true brain of the device, studies that flood of numbers. It watches you try to move again and again and learns which firing pattern means up, which means left, which means click. It is learning your brain's private language. Then the loop closes. Your decoded intention becomes a real move on screen in a fraction of a second. The cursor jumps, you react, and when it drifts, you correct. The model quietly relearns, and with every round, your control gets sharper. This is not science fiction. In 2026, brain-computer interfaces are helping people who are paralyzed type and speak again just by thinking. Neuralink is even trialing a device called BlindSight, aiming to feed vision straight to the brain for people who are blind. The point was never the gadget, it is independence. A mother speaking to her kids again, a hand reaching for a cup, a blind person seeing the outline of a doorway. That is why engineers are racing to build these implants in high volume and make them last. But it is genuinely hard. The brain is warm, wet, and alive, and it slowly wraps scar tissue around any implant, muffling the signal over time. You can only read so much at once, and it all has to be perfectly safe inside a living head. But step back and look at what we can already do. We are reading the brain's own electrical language, one tiny spike at a time, and handing people back their voice, their movement, maybe even their sight. Follow for how the frontier is really built.